cool. Thanks for showing up. As you know, Box has a really big focus on security. It's a big part of what we do, and I have the pleasure of introducing Michael Coates. I used to work with Michael at Mozilla, and right now he works at Shape Security, but he's also the chair of OWASP, which is a very important initiative, and he can maybe talk about that. But I love WebGoat, going all the way back to the days when I was a software engineer myself. I'm Mike Morgan, I'm a director of engineering at Box, and I hope you have a good time. So, hand it over to Mike.
Alrighty. Well, first of all, thanks so much for having me here. It's great to be able to get in front of an interested audience of developers, security people, and talk about something I love. I've been doing security for a long time, and if you give me a stage and a microphone, I'll talk your ear off about some of this stuff. So we'll have a Q&A session at the end, but in all, realistically, I like questions throughout. So if you do have one, don't hesitate. There's a microphone stand up here towards the front so everyone can hear your question, including me. So if you come up there, I'll see you, and we can talk about that. So I'm going to talk today about a topic called creating self-defending applications to repel attackers. The title makes a little bit of sense, so I think you have an idea what we're getting in for, but let's dive in. So a little bit about myself. First off, if you somehow get into a situation where you can get a picture like that taken, why would you not use it like that? So there it is. So I'm the chairman of the OWASP board. How many people here are familiar with OWASP? Awesome, that's great. So OWASP has been around for over 10 years now. It's a nonprofit organization. Believe it or not, we are in over 100 countries around the world with 35 to 40,000 participants, depending how you do the math. And that organization is dedicated to advancing the state of application security through free and open resources from everyone. So that's my night job. And my day job, I'm at Shape Security. That is a startup based in Mountain View, and we're doing some amazing things with protecting websites from advanced attacks, specifically in the automated space. There's a bunch of different shapers here tonight, and lots of things I could tell you about that afterwards. There's one of them raising his hand over there. In terms of what I've done, I've been in security for the last 12 years or so. I'm not sure if you can see the text on the screen. Some interesting things over that time. I was at Mozilla leading the security program that protected just under 500 million users around the world. That included Firefox, Mozilla systems, services. I worked before that securing code that processed millions of dollars every day. I've had the opportunity to do penetration testing against online voting systems. An interesting fact about online voting systems, the paper-based version of online voting systems, so just doing the paper ballot, one of the attack vectors you can think about is actually using a different type of paper. So it's kind of interesting how when you look at different systems, what comes out. Defended a Fortune 100 global network, had the opportunity to infiltrate telcos in Southeast Asia from a mobile connection in the US back in 2007. And the last one's kind of an interesting item for conversation. As it says, quote, talked my way into bank vaults and server rooms, all legitimately. You would be frightened to know that about half the time that was successful. So, something interesting to think about. So to set the stage for what we're talking about, why is security important? It's something that I'm obviously interested in. There's a handful of people here that it's probably your full-time focus. But why is it that you should care that I care? And so on the screen here, there's a bunch of different numbers. Starting from the Walmart annual revenue of 2013 at $469 billion, all the way down to the GDP of Morocco at $95 billion. And the question I have for you guys is, where do you think security falls in there in terms of a global price tag? And I guess I've already given away some of it, that it's between 95 and 469 billion. But it's quite sobering to know that the global price tag of consumer cybercrime eclipses things like HP's annual revenue last year, or Honda, or the country of Morocco. And so it's a difficult thing to measure, but when you look at some estimations, this is a pretty major deal of what we're talking about. $113 billion for consumer cybercrime. Now those numbers are definitely not going down. When measuring that from 2012 to 2013, there was a 26% increase for the cost of companies. The individuals across that time had a 50% increase. And if you want to do some rough estimates on how much it might cost your company, the average cost per record breached is around $136. So if you have 10,000 or 100,000 records, and that was breached, you can do some math and see the kind of numbers we're talking about. The largest culprit that's leading to data breaches, to these impacts to companies, is related to hacking. There's two different statistics that I would definitely point at. One is called datalossdb.org. That's a website that tracks different data breaches across the net. Their statistics from 2013 show 48% were due to hacking, and the Verizon data breach report for 2013 mirrors those numbers, showing that 52% of the issues were due to hacking as well. And has anybody looked at that data breach report that came out just recently, 2014? There we go. So I haven't dove through all the numbers yet, but they had a nice timeline of the different types of attacks and the rate of those across all their reports. And so what you see there in the very top line is that hacking is definitely not going down. So we can talk about social engineering attacks, we can talk about malware. Those are definitely problems. But we haven't stopped the people that are attacking us through the front door with good old-fashioned hacking. Now, there's a few different types of ways people are coming after our applications. And the kind of scary thing is that according to the 2013 data breach report, 75% of the attacks were considered opportunistic. And so this means it's not about us thinking about the crazy ways in through the side door or digging in through the basement of the house, dropping in through the chimney. We're essentially leaving the front door open, and the attackers are just walking in the front door as they walk down the street. That's what opportunistic attacks mean, more or less. And that's the state we're in for security. So we definitely need to get past this very basic point of just securing the front door so that we can start thinking about the more advanced ways people are attacking us. And when you think about opportunistic scanners and attacks, those people may not be directly targeting you. Instead, they're scanning the web through automation for vast numbers of vulnerabilities and saying, oh, look at this. This one happens to be vulnerable to this very generic thing. I think I'll focus my attention here. And the reason people are attacking websites, it's not just the kids sitting in basements. It's not just activists trying to make a point. Both of those people do exist, but it's also organized cybercrime. And the reason that is so is because there's money to be made. And anywhere there's large amounts of money to be made, groups will form, legal or illegal. And if you take a look at the underground market prices, you can start to get an idea of how they make their money. A credit card goes for $4 to $8. Now, if you think about when your credit card's stolen, you have fake charges on your account, the amount of time you put in, I think $4 to $8 seems pretty paltry and kind of insulting. But at the same time, when you think about 10,000 credit card numbers being stolen, that nets the attackers $40,000 to $80,000 right there. You can see why they have that financial incentive to continue attacking. And those numbers go up. A credit card with both Track 1 and Track 2 data will fetch you $12. If you have the full information, that's $25. Now, also interestingly, on the underground market, you can buy 1,000 infected computers for $20. And you can rent a DDoS attack at $3 to $5 an hour. So you can see how the world goes around here with the underground criminal organizations. They have entities of financially motivated employees, more or less. They have a marketplace to sell those sell the stolen wares. And if anybody gives them trouble and they need to shake somebody down for $5, they can bring down a website with a DDoS attack. So a pretty scary scenario that we're dealing with. So when talking about self-defending applications, what is our goal? What we want to do is protect our most critical data. There's a lot of things out there to protect, and if we try and protect everything equally with the same vigor of controls, we're going to face an uphill battle. So first, let's protect the most critical data. We want to handle both known attacks and also unknown attacks. Because if we rely on a signature-based approach for defense, then we're just going to be compromised by something that we haven't seen yet. Signature-based defense is only as good as the last thing to compromise somebody. For a self-defending application, we need to be able to identify the attacker before they compromise us. I probably will mention it a few times, but if your strategy for knowing when you're compromised or under attack is waiting for New York Times to put on their front page, you probably need a new strategy. And lastly, a self-defending application needs to be automatic. The human is too slow. We know that attacks can be launched through code, through automation, and if we're waiting for someone to spot something in real time, take the activity to block something, even if they see it immediately, we're already too slow. And we know that they most often don't. Those alerts, those log things get reviewed weekly, monthly. You can say, hey, last month we got compromised. That's also not a good place to be in. So when thinking about your critical data, I think everybody probably has this in mind, but we have name, email address, credit card, bank information, medical data. And the tricky thing about critical data in applications is you can't just design those away. You have to have those in the application. That's the point of whatever amazing application you're building, to deal with this information and provide something of value to the user. If we look at the different types of things we're doing for defense, we're not there yet. And that's why I want to talk about self-defending applications. Because we have custom code in our applications, we're going to have custom vulnerabilities. As every one of you knows, Microsoft isn't going to help us and give us a patch to help our custom web app. We're relying on unrealistic defensive postures. We talked about signatures. They're only as good as the last way someone was compromised. Human-required interaction is too slow. And the fact of the matter is our applications are being attacked all the time, constantly. And the sad thing is the attackers really have no reason to stop. And so a lot of the motivation for this research and this project came because I was hired for many years to attack banks. And so I would go and I'd sit down from my home office and I would attack a bank somewhere in the country. And the very first week I did that, I worked through the application flow of the bank. I submitted a mortgage application. And at the very end it said, would you like to submit another application? Which, first of all, from a usability standpoint, is a little odd. I don't know how many people want to submit multiple mortgage apps to the same bank. But nonetheless, I was monitoring my traffic with a proxy tool. And as I hit yes to submit another mortgage, I saw a hidden parameter go by that had ID. ID equals, 1002. And I thought that was also interesting. So I changed that from 1002 to 1001. And lo and behold, everything worked. And instead of submitting another mortgage app, I hit view my account. And suddenly I was Susie Joe, and I viewed all her past mortgages. And so if you see where this is going, I just iterated through those different IDs. I could look at every single account, download their whole life story. You have everything in your mortgage app. And this was the first week on that job. I thought I hit the jackpot, I'd get a major award. Nope, that was the kind of issue that we found every single week. And this is for banks. This is from my house. You can't really get that much worse. And so as I kept banging on banks again and again, it occurred to me, why is it that I can keep doing all these malicious activities? Why can I mess with integers in the URL? Why can I change hidden fields and send garbage through HTTP requests? And nobody ever blocks my connection. Nobody ever kicks me out of the system. Why does somebody not show up on my doorstep like we see in TV? You type in a command and suddenly the FBI is over your house. None of those things happen. And so that's where this project started. It's ridiculous to stand there as an application and let somebody punch you in the face again and again and just take it. So here we have self-defending applications. So if you mocked up a very basic application and kind of separated out some different components, there's a lot of different ways an attacker would look for vulnerabilities. I would go after request processing and session handling. I'd see how you do your session IDs, if you invented your own system and I can guess the next random number. I'd look at authentication. You might have a really great password requirement, but if I can do forgot password and change the hidden value of the URL of the email address and send myself the forgot password link, that might be a way in. I'd go after access control. I'd log into your application and say ID equals 113 in the URL. I change that to 112. The reason I called that out separately from the mortgage application is because that attack would be very relevant if you were one of the largest banks in the country and it was 2 years ago. They had an issue where you could change the account number in the URL and you would see somebody else's account. In terms of input validation, we look for some of the common things: cross-site scripting, SQL injection, just dumping tons of bad data all over your application, seeing what sticks. And we attack things like business logic. And one of the things I talk about when I give training on developer security is this idea of just because I can't see a functionality in your application, don't think I couldn't craft a custom post message to try and invoke it. And so that's something I would do a lot in these assessments. Oh, there's an edit user. What about if I change the post of edit user to delete user? There was never a button that said delete user, but I'll make an intelligent guess and see, could I delete this person and invoke this functionality that wasn't displayed in the UI. So how do we take what we know an attacker is going to do and how they look for vulnerabilities and use that against them? So stepping through all those different items, we know that an attacker can cover any different part of the application looking for a vulnerability. We don't necessarily know what vulnerabilities we have in the application, because if we did, we'd probably patch them. We of course know there's a backlog of things we haven't fixed, but the critical ones bubble up pretty quick. We fix those pretty quickly. But where are those hidden vulnerabilities? Where are the ones we haven't found out about and that could really bring our system to its knees? And so the idea is not to try and solve this overall problem of finding every single vulnerability known or possible, but instead to look for someone doing bad things. Because I, as a former attacker, know what I would do when I attack your app. So why don't I tell you that? These are the ways I'll attack your app, and I'll give you a list of them. And what you'll do is build into your application different alarms or detection points to look for somebody trying to do that kind of probing for your application. And what you can do is make some intelligent guesses about what's going on. You could say that an individual that puts a single tick into an input field is trying to look for SQL injection vulnerabilities. That'd be a very rudimentary way of doing that. But you could also say that same person just missed the enter key and kind of fat-fingered that. So we don't necessarily want to kick out everybody that puts a single tick. The Irish wouldn't like that either, all the O'Malleys, O'Sullivans. But we do know that someone that is changing a hidden field did not accidentally open up a proxy, configure their browser, intercept the request, and change it to something else. That's not something you accidentally do. So what we know from that is that the second person is definitely up to something no good. And so that is where we get to the idea of looking for badness before the attacker has compromised the application. So in the project called AppSensor, which is kind of the basis for self-defending applications, we've built different detection points. We have over 50 of them right now and continuing to grow as it's an open source project. And what these do is detail out the different types of way to look for bad guys. What are all those different things I would do when I attack your application? And they're broken down into two different categories. Signature style detection points and also behavioral style. And then for each of those we go into different categories like request exceptions, authentication, session, access control, to help you kind of guide you where you want to put them in your application. And from those we'll provide details on what you're looking for and what to be aware of when you're implementing the different feature into your code. So as I mentioned just a moment ago, a key item about this is you don't want to have detection points that could be accidentally exercised by a real user. And when you think about things that way, with that kind of perspective, the detection points that we've come up with actually have essentially a false positive rate of 0 more or less, because of the kinds of things that people just don't accidentally do. Another example is a page that is designed for get requests that suddenly gets a post request. Again, a post is not something you can really accidentally submit. And unless you're on a security website, you're also not going to get the data single tick space or 1 = 1. Also not another item that you would accidentally type in. So those are scenarios where you know someone's up to no good. And what you do with that, with those detection points, is you hook them up to a central brain in your application or a knowledge source, and you can then map those against the user. So if you see a user moving through your application, they suddenly submit a post request where they should have only submitted gets. They change a hidden parameter. They start sending very malformed information that's definitely malicious. We can tie that all together and say, this user is up to something. Now, one of the key items of this I hadn't mentioned yet is that this works most effectively inside the authenticated portion of your application. And that's okay. We don't want to necessarily protect the outside of the application too much. The most sensitive data and operations you have are all going to be within your authenticated portion most of the time. So with that kind of assumption, we know that once the user is authenticated and logged in, we know who they are as they move through the website. So if they start doing a lot of different malicious activities, what we can then do is take action against that user account. We can lock them out. We could just log them out of their account and make them log back in. Maybe it was a temporarily stolen session ID. Maybe their machine was left open and somebody sat down on it. But there's a lot of different things we can do to thwart the authenticated user and basically punt them outside of the application. And as long as you have strong controls that don't fail in your authentication, we've removed the threat from the scenario. And the reason this all works is that I, as an attacker, it's going to take me a lot of requests to find a vulnerability in your website. And even if I'm on a page where I know a vulnerability is present, let's say there's a cross-site scripting vulnerability, it's still going to take me a handful of different attempts to find the right permutation of the attack so I can make it weaponized, make it break out of the appropriate HTML tags, fire off the script, be silent. And that's going to take me a handful of different requests. But from this AppSensor self-defending perspective, it's really only going to take us 2 or 3 or 4 obvious malicious activities for us to say, yep, this guy's bad, we want to get rid of him. So if you're in this scenario where AppSensor can detect a bad guy before a bad guy can find and weaponize a vulnerability, we're going to win that race. We block that account, we kick them out. So even if we don't know what they're looking for, as long as we can tell that they are bad and malicious, we can get rid of them before they do their ultimate evil or compromise. Now I mentioned that there were 2 different types of detection points that we've categorized, both signature and trend-based detection. The signature-based detection points are based on what kind of information they send to the application. So if they're sending the, let's see, maybe they send the trace HTTP request, and then they change that trace to a get, to a post, or to an imaginary one, if you've heard of HTTP verb tampering. Those are all signature-based detection points. But the other element to consider is, what if your functionality is being used at a higher rate than you would normally expect? What if suddenly your update address functionality was being used multiple times a day or 100 times an hour? We have no idea why an attacker would be doing that, but it's certainly not normal. And they could be looking for a flaw and trying different iterations while they're using an otherwise normal piece of functionality. So these turned into basically behavioral-based detection points. When you're exceeding normal thresholds of usage, that indicates something's going wrong. Now, an interesting story on that, a few years ago, actually it's been several years ago, the website, let's see, it was MySpace, was attacked by something that would have benefited from trend analysis. There was a guy named Sammy, and if you've heard of this story, so Sammy wanted to impress his girlfriend, and he thought he would impress her by how many friends he had on MySpace. And one way of getting friends would be to go make friends. Pretty obvious. But Sammy thought that was not going to work for him. Instead, he decided that his technical abilities would help him acquire friends. So he found that he could add some JavaScript into the page that would invoke the add friend, and also that he could add some JavaScript that would update their status. And so what he did is he created a little bit of code that when someone viewed his profile, they would add him as a friend and update their status with the same code. So when someone viewed their profile, it would also add Sammy as a friend. And so I think we have people here in CS that can see where this is going. We're talking about exponential growth. So he had friends. After an hour, he had a few hundred friends. After another hour, he had several thousand. And then he started getting to tens of thousands of friends. And he started to panic, realizing something had gone horribly wrong. He frantically tried to contact MySpace. I don't know if he got in touch with them or not, but after 19 hours, they brought MySpace down, one of the largest websites in the world at the time, because the code was out of control. Even though he told them exactly what he did, apologized, I don't think MySpace pressed charges. Unfortunately, the feds did, so he had some time to reflect on that. The point of this, though, I took this idea and the AppSensor concept, kind of recreated a social networking app with the same sort of vulnerability. And I demonstrated that if we put in behavioral analysis or trend detection, we could see that the update status or add friend feature was peaking. It was going far above the normal usage patterns on a given day. And what an application can do is respond to that by saying, let's disable update status functionality and stop whatever this thing is that's shooting off the charts. We can then investigate, see what's actually going on, but we'll be in a situation where the application itself will stay up. Whatever the problem is that's spiraling out of control will be paused, and we can figure out what's going on. I kind of compare this to like a submarine type defense. Just because there's a hole in one part of the submarine doesn't mean you all die. It means you close off the room. And I think when we think about critical applications, we can use that same sort of mentality to shut down a functionality temporarily while we investigate the other roots of what's going on. So some of the different trends that you might look for, irregular use of the application, and that could be speed. You certainly don't normally move through the application page by page in milliseconds. At least a human doesn't, a bot does. How often you use the site. If you normally use the site once a week and suddenly they start logging in every night at 2 a.m., that's odd. Frequency of feature, like we said, the update address, you wouldn't invoke that hundreds of times per second. And you can look at that both at a user level and also across your entire application. What are the trends overall? If there's suddenly a high number of logouts across your entire application, what happened? Do you have some sort of CSRF attack that's logging everybody out? And the same thing with high number of logins. If suddenly tens of thousands of people are logging in where it's normally hundreds, that's concerning. It might also be concerning if it was just days after the Adobe breach and what was it, 46 million usernames and passwords were exposed? If somebody took those, and you can get 6 million of them right now. You can just download them, and they've reversed 6 million of those usernames and passwords. How many of those work against your application because somebody reused their password on 2 different sites? So if you suddenly saw a high number of logins, maybe someone's abusing this functionality in an automated way against you. So in this project, we go through the different detection points. We talk about what they are, give a description, give some information about how you might want to tune this to make it work in your application, and provide some examples on how to do it. Now, one might say that this is all great ideas, but anybody can come up with kind of a half-baked idea and just start talking about it everywhere. So a little bit of comfort. This project has gotten several different adopters contributing to it. We've talked at Department of Homeland Security, and we're part of their software assurance recommended guidance. And it was also published a couple years ago in CrossTalk, which is a Department of Defense journal. So the idea is definitely taking hold. Now, if you weren't going to use a self-defending type approach, well, first off, the reasons I believe self-defending apps are so powerful is that it's inside the application. The ability to interact with the user itself is really the power of what we're doing. We want to be able to block that account, log out that user. If you look at a different approach that tries to provide defense in the space, like a web application firewall, the problem with those approaches is they sit outside of the application. So the only thing they can see is if you do a generic attack that they know about. Like, oh, here comes a generic SQL injection attack. Well, that's great. So the SQL injection attack doesn't work with 1 equals 1. What if they put 2 equals 2? Sometimes that will actually get around the WAF. But the critical stuff, as we talked about, is all in the authenticated portion. And that's where you have things like access control violations and custom business logic flaws. If the business logic of a purchase is 4 steps and I jump from step 1 to step 3, a WAF is never going to see that. That's all legitimate traffic. But somebody could have just bought a free TV off your website. And speaking of free TVs, A few years ago, one of the vulnerability was that the price was passed as a hidden parameter. So people just changed that price and got free TVs. So the sad thing is all of the vulnerabilities that we see are not just made up and interesting, they're actually all real things that have kind of annihilated us over the years. SQL injection was actually found very prominently because there was a piece of ASP code on a website, and they said, how do I do username and password login with a SQL backend? And somebody gave an example of how to do that, and that was vulnerable to SQL injection. And then there were tons of websites on the web for many years that all had SQL injection to bypass the login for anyone. But back to alternatives. Aside from a WAF, you could do log analysis. But again, that's only as good as the logs you have and how fast you are in reacting to it. So I think that an automated approach that's inside the application is really the best way for us to move forward to have hope in providing these types of defenses. So I want to talk a little bit about when we implemented this at Mozilla and how we got this actually working in some of our applications, some of the data we got back from it. So we implemented this in our applications by kind of piggybacking on the existing logging framework. We used something called Ceph, Common Event Format, which was easily parsable by the SIM. And what we did is have the developers add specific AppSensor logging points. So we took those 50 different detection points and we said, we're going to do these 6. An access control one, a few input validations, some stuff related to database interaction. And we want some extra logging code added around these items. And one of the common questions I get is, what's the performance on this? Does this impact how fast the application is, how fast the application runs? And the answer is it really doesn't impact it at all because we're only in the exception flow. We're only taking an action when somebody violates access control, for example, or gives us data that is not valid. So it runs very infrequently. But when it does run, when that code does run, it'll just call the standard logging library and issue a message that we pass along. Now, Ceph was handled over syslog, so we were able to wire up our systems so the web heads, application servers, and even the OS could all communicate back to a central brain, or SIM in this case, and gave us robust knowledge across the entire stack. And so we were able to see, at the application layer, what kind of people are doing interesting things in the application, trying to violate access control, looking for flaws. How does that correlate with things going on at the network layer? Do we see triggers from our IDS? Do we see Nmap scans? Different sort of attacks at the protocol layer. And then also on the OS, do we see anything suspicious happening at the OS itself? Now, clearly, if something bad was happening on the OS, we'd have to really scramble because that would mean someone's out of the box and things are going horrible. But you certainly want to have that visibility. But once you start bringing all this information together, you can see some interesting patterns and graphs of what's going on. You can look at your failed CAPTCHAs on create of accounts. You could look at how many user accounts are being created by IP address or by time of day. You can see trends across user authentication failures. You can map those things to see how they vary by day and by hour. And by doing so, you can build baselines that say, oh, this is our normal usage pattern. And then you can see something spiking and going out of control. Now that spike may mean that you were featured on Slashdot and everything's okay, or it may mean that you're being targeted by a new type of attack, and you at least saw it before it started doing damage. You can also build tables that show, what are the top users that are failing authentication? Is somebody targeting Joe Administrator across a bunch of different IP addresses? Because it's easy to see when one attacker from one IP address unloads on your site with a brute force. But what if that attacker, instead of using a botnet and sending one failed request per IP and then bouncing all over the world? That's a lot harder to see unless you bring that together and say, oh, all these different IPs are all attacking Joe Administrator with one request each. And one of the other things that we did that's an interesting learning situation is to visually map some of the activities that were happening. And in this graph, there's an operation that's represented by a square, an IP address that's a red square, and a user account with a blue circle. And when we started out, it just mapped the items on the screen, and we had really no idea how to interpret it. But as you start to look into it more deeply, you can say, okay, here's a change password operation and a series of users that are invoking it. Here's an authentication failure that's coming from a bunch of different accounts. That makes sense. And here's some users that are making new accounts from IP addresses. But by doing so, you also may be able to see patterns that you hadn't recognized or thought about previously. If you see somebody do an authentication failure multiple times, and then suddenly a password change, and it's a successful login before that, you can start to wonder, oh, did they brute force an account, suddenly get in, and then change the password? Or if you have one IP address that's controlling 100 users, that seems pretty suspicious too. Maybe it's a university, or maybe it's something really funky going on. And just like authentication failures and then suddenly new accounts, maybe something's at play here where they're trying to get a new account, they give up, make a new account. Maybe it's good, maybe it's bad. But by visually mapping this, we get ourselves in a situation where we can learn new things and then build pattern matching or analysis to find those in our application automatically. So I feel like there's tons we could go into on this topic, but as time permits, we'll wrap up here. A few different points I really want to drive home. Self-defending applications, I believe, are one of the few hopes forward. If we keep using the old ways we've been doing things, we'll keep getting compromised, and it's not getting better. I've watched, I look at the news every morning, and for the last 12 years in security, I remember for months never seeing anything about security and going, oh, this is interesting, it seems pretty important to me. But now I see it every week, and sometimes every day. A news story about a major breach, a major vulnerability. We're not trending in the right direction, unless you're thinking of job security for security people. And as we try and defend applications, with the type of motivation attackers have, with criminal elements, with financial incentives, if we're not responding immediately, automatically, we really just don't have a hope. We need these systems to be able to defend themselves against the types of attacks we're seeing. A few things if you're interested in these ideas. The OWASP AppSensor project is where this all started. We have a growing number of contributors to it. A book is going to be released, the second version. So many years ago, the first version came out with some of these ideas. The team buckled down and made some amazing improvements. So we have another book coming out in just 6 weeks, I think. That's totally freely available online.